Hi everyone, welcome back to part B of week 10 lecture on uh, data modeling, normalization, and ERD2 database design transformation recap lecture. The second part is basically on normalization. So let me share my screen again. So this lecture is on normalization. There are a number of normal forms: first, second, third, BCNF, fourth, fifth, and sixth normal form. But in recap, I shall be touching upon only major four. That is quite important. Those main four normal forms: first, second, and third BCNF. Um, let's move to the next slide. So, what is the normal form actually? A well structured relationship is one that contains minimum redundancy. That is a well structured relationship model, and minimum redundancy that allows users to insert, modify, and delete the rows in table without errors and inconsistency. That will be explained in the following slides in detail. Relation that is not well structured always carries some anomalies whenever there is any update attempted in the database in the table. So either you are inserting any new row or deleting any existing row or trying to modify any existing row, that introduces anomaly, and that is well explained actually in the following slide. So for example, let's go to the insertion anomaly. In this slide, insertion anomaly is shown here, that if you are interested to introduce a new program, for example CF78 program ID, graduate certificate info system, and if there is no student registered for that particular program at this stage, you can't put that particular entry because student ID is a primary key, and without having student ID you can't make any entry. So that's the insertion anomaly. You can't insert a new program without having student ID defined and without having a student. That anomaly is there. That's called the insertion anomaly. Second anomaly is the deletion anomaly. So for example, in previous slide, which we saw, suppose Rakesh Singh in the top row, student number one has got a program CF74, that's Master Information Info Technology, and he is only one student in this particular course. And if you delete that particular row, the whole course is disappeared. So the whole program is disappears. That's a deletion anomaly. It's deleting one student, that's last student of the class, and the whole course, whole program is deleted. That is called deletion anomaly. The third problem which we discuss about modification anomaly is that if you're trying to modify the program name from master information systems to master of informatics, you need to actually do modification everywhere wherever is master info system appears, and that's the modification anomaly because there is high chances of missing out some of the rows where this particular course name should be modified, and that's called modification anomaly. um, and that anomaly is because there are two tables are merged together. For example, student information is student name, date of birth, and which program student is registered or enrolled. That is one table, and another table is program ID and program name. The two tables are merged together as program information table, and that's why this anomaly is appearing. Um, Before going to the normalization, let's actually have another clarity on another concept that's called the functional dependency among the different attributes. So in this particular table, you can see student ID has got student table has got actually how many five attributes: student ID, name, date of birth, program ID, and program name. So student ID is a primary key, you can say here, and student ID determines the name. So that's called student ID is called the determinant. Determinant means every student ID determines the name of the student, date of birth of the student, and which program that student is registered, enrolled. Uh, that's how this particular relationship, this particular dependency is called functional dependency. So student ID is having functional dependency, determinant, working as a determinant to the different attributes. Sometimes there is composite functional dependency. In the previous slide, it was single attribute. Student ID was able to determine other attributes, but in this particular case, just in normal situation, in normal university, every student can register more than one unit. So suppose you want to actually get the grade obtained by a student in a particular unit, you need to have a student ID and unit ID together to identify that grade of the student. And that's why the student ID and unit ID together works as um, primary key, or you can say identifier, and these together determines grade. So the, this is called composite functional dependency determinant. So student ID, unit ID together determines grade. Let's go to normalization. So what is normalization? Normalization is a formal method of determining whether a table is well structured or not well structured. If it is not well structured, normalization provides a process to decompose relations into a number of tables, a number of relations, which removes anomalies of insertion, deletion, and modifications. So that's a very formal definition of normalization. Uh, uh, um, as I said actually earlier, that there are number of normal forms. The first normal form, second, third, Bayesian, fourth, fifth, and domain key normal form. But for the recap point of view, we are just going to discuss the most popular normal forms are the first four one, and we are going to touch first four normal forms: the first, second, third, and Bayesian. So let's start with the normal form definition. So first normal form is called uh, uh, a very basic normal form, and it has got some condition. A table is called, a relation is called first normal form if does not have any composite value. Composite means complex value. Or repeating group, also called repeating group. In this and it has got a primary key. So in this particular table, in customer table, you can see customer ID is a primary key, but the uh, order details, you can see it has got a composite values, the complex value. It's not a simple value or not single value as well. So it has got actually order number, date of the order, amount. So that's a composite, it's a complex, it's called the repeating group. And that's why this does not satisfy the first normal form's condition. In order to convert that to the first normal form, you have to remove the column which is having repeating group or having composite value. So in the previous table, you can see the column, the order details has been broken into the other table. So you got a customer table, customer ID and customer name, and then you've got actually order table, order ID, date, total, and customer ID. So customer ID, which is the primary key in customer table, becomes a foreign key in order table. and that's how actually it is broken into two, and that satisfies first normal form. Let's move to the second normal form. In the second normal form, the condition is that actually the table should satisfy first normal form condition. First of all, it should be first normal form, and then table should not contain any partial dependency. What does it mean? Partial dependency means there are composite candidate key. Candidate key means primary key. Suppose primary key is composite key, x and y together. You have seen actually in the previous slide where student id and unit id together works as a composite key, or the primary key in this particular slide. So student id and unit id together works as a composite key, a composite uh, called composite key, a primary key that determines grade. uh, in second normal form, you say actually there should be composite, there could be a composite key xy candidate key, but uh, there should not be a partial dependency. It should not be like that actually. The part of xy together, for example x determines z or y determines z, so part of the composite key should not be determining any attribute. So let's understand actually through this particular table. So for example, this student id and unit id together is a candidate key, or you can say primary key, that together determines grade. That's fantastic, that's great. But in other hand, you see the student id itself is able to determine student name. It's the part of the primary key, a part of the candidate key is able to determine a student name. That's called the partial dependency. And once there is a partial dependency, that does not satisfy the second normal form. To convert this partial dependency kind of table into second normal form, you have to break this table into two parts, and that um, removal of the partial dependency is shown over here. Student id unit id together with the grade becomes one table, grade table, and then student id and student name becomes actually another table as a student table, because they are partially related with each other. So that's how actually it converted to the second normal form. Let's move to the third normal form. The condition of the third normal form is that the table should satisfy the second normal form. It should satisfy first normal form, second normal form, and then it should not have a transitive dependency. Transitive dependency we have seen somewhere in the previous slides, but I'll discuss it back again. There is a candidate key x, and x determines a non-key attribute y, and y determines non-key attribute z. So that becomes transitive. Let me explain with the example here in the following slide. So this table you have already seen in the previous slides. So for example, student id is able to determine name, student id is able to determine date of birth, student id also determines in which program student is enrolled, but it is not able to determine program name. Program name is determined by program id. So program id is transitive relationship. So under that situation, student id is able to go to the uh, able to determine program id, but program id is able to determine program name, not student id, and that becomes transitive dependency. Under that situation, this particular table is not able to satisfy third normal form, and for that uh, this has to be removed in order to meet the third normal form condition. And that's how this table, the earlier table, is broken into two parts: student table and program table. Student table has got the student id, name, date of birth, and program id, and program table has got program id and program name. That's how this is broken into two parts. um, Last bcnf, last normal form is bcnf, bias code normal form. In bias code normal form, there is condition that uh, table should be satisfying the third normal form, and it should satisfy a relation is in BCNF if and only if the third normal form, it should satisfy third normal form, and determinant is a candidate key. So, for example, determinant is the primary key, the candidate key, not the non key. So, in this particular table, you can say student advisor table. Determinant is student ID. Student ID is able to determine who's advisor of a student, but at the same time you can say advisor name also determines who is student of that advisor, and advisor name also determines major, which major advisor is advising. So the advisor is you can say is professor of a particular major. So in that case, advisor name is determining major rather than student ID is determining major. So under that situation, student ID, this particular student and advisor table is not able to satisfy BCNF because a non-candidate key, non-primary key is determining one, uh, one determining uh, you can say candidate key as well as uh, a non-candidate key, non-candidate attribute, the major attribute. Under that situation, it has been broken into two parts, and the student advisor table is left with student ID and advisor name, and the advisor major is broken into another table, and advisor name and major name. So this way, we completed the BCNF normalization condition to satisfy this particular table. So this way we completed part B, and we'll come back to cover part C of the lecture. In part C, we are going to cover ERD to database design. Thanks for attending part B.